Here I have a question or a problem in which we have the value of f2 is unknown, and we need to calculate the value of f2. We will apply the rules of equilibrium to calculate the value of f2. So to start with, we need to resolve the forces into their components in x and y direction, and starting with this is x component for f1, and this is y component for f1, and this is the x component for f2, and this will be the y component for f2. So I'll call this one f1x, and this is f1y, and this will be f2x, and this is f2y. And if you have noticed, f3 has the vertical component, so we might say this is a horizontal component, or f3, and if we want to call it f3x, but this is equal to 0, because this has no x component to it, and so sy component is the same value of the force itself, so f3 is equal to f3y. Now the value of f1x is, we can calculate the value of f1x because we know the angle. So this is 35 degrees, and this is 75 degrees, and this is the cosine. So f1x is equal to f1 multiplied by cosine 35 degrees, and because we know the value of f1, which is 6.88 kilonewton, multiply cosine 35, the value of fx is equal to 5.635 kilonewton, and f1y will be equal to f1 multiplied by sine 35 degrees, and f1 again is 6.88 kilonewton, sine 35 degrees is equal to 3.946 kilonewton. For f2 x, because we don't know the value of f2, so we continue f2 multiplied by cosine 75 degrees, and the cosine 75 is equal to, so it will be f2 multiplied by 0.258, that is the cosine. So ultimately the answer is 0.258 f2, and f2y is equal to f2 multiplied by sine 75 degrees. Same goes here, f2 multiplied by 0.966, so the answer is 0.966 f2. So now to calculate the value of f2, we can apply the equations of equilibrium, and we can start with either all forces in x direction equal to 0, or all forces in y direction equal to 0. Both of them will be valid to calculate the value. So if you look at the x component forces, we have one force here, we have one force here, and this is 0. So we'll add these one at a time. So we have f1x is going towards east, so it is plus f1x, and f2x is going towards west, minus f2x, and f3x is already 0, so we don't need even to write that down, so it's equal to 0. So this is our equation. and the value for F1x is equal to 5.635 kilonewton, and F2x is equal to 0.258. F2 is equal to 0. So isolate F2, 0.258. F2 is equal to 5.635 kilonewton. So F2 is equal to 5.635 kilonewton divided by 0.258 and is equal to 21.84 kilonewton.